Hi! What did you write for your explicit and recursive definition? I'm kind of curious, but I know it's pretty good, okay? I trust you that it's really good and really strong and something that you will remember, okay? The difference between the two formulas, okay? Now, I want to go over a little bit of a calculus concept with you. It's called limits, and that's on part 2 here. Limit of a sequence. Yes, sequences could also have a limit. Let a sequence a sub n be a sequence of real numbers if the limit listen to the way that I'm reading this, okay? The limit of a sub n as n approaches infinity, or limit as n approaches infinity of the sequence a sub n is a finite number, L. The sequence converges, and L is a limit of the sequence. If limit is infinite or non-existent, the sequence diverges. Wait a minute, what? So wait. If a limit of this is a finite number, L, the sequence converges. Oh, so if the limit goes to a finite number, then it converges. But if the limit is infinite or it's non-existent, like it goes on forever and ever, then it diverges. So we'll do a few examples so you get a better idea. But of course, in calculus, all these skills will be definitely clarified for you completely, okay? Finding the limit of sequences, determine whether the sequence converges or diverges. Basically, the only thing that you have to remember is converge means that it reaches something, some number, and diverge means it goes infinitely and it does not converge or go to a specific number, okay? It goes on forever. So for example, here, okay, 1 over 1 over 1 over 2, you can see that this is a sequence, and if I told you to write the next 3 in the sequence, I bet you can do that very easily. And you can see that the explicit formula is 1 over n, because that's how it behaves based on the position of each of this value in the sequence, okay? Now, it keeps going, right? It keeps going, okay? Determine whether it converges or diverges, and if so, give the limit. Again, this guy too, 2, 3, 4, 5 on the numerator, denominator is 1, 2, 3, 4, and of course you understand how this converges, okay? I mean, you see how this sequence works, okay? And then C, 2, 4, 6, 8, 10, you see how that is, just even numbers starting from 2, and D is an alternating sequence of -1, 1, -1, okay? And so forth, okay? So now, let's formalize these so you have a definite technique, okay? Like, you don't understand, like, does it mean that this is converging? Does it mean that we're taking the sum? Well, no one said anything about a sum, so we know for sure that we're talking about something like this, okay? So what we need to do first is to think of the formula, the explicit, okay, formula, because this guy right here, you see how this here, what I'm going to do is I'm going to write that, look, here, limit as n approaches infinity as a sub n, right? This guy here, a sub n, is your explicit. Not explicit content, explicit formula, okay? So don't forget that. So by now, we know how to write explicit formulas, right? So we're going to go like this. Limit as n, oh, whoa, yeah, my pencil's acting really funny today, so we'll have some fun times, okay? N approaches infinity, okay? Okay, of this right here is your a sub n. Now, this 1 over n, it's going to go on forever and ever, infinitely, right? We're wondering, what is it going to? Like, what is it reaching? Is it reaching anything? So I want you to imagine this. I have one pizza. I want to share with 5 people. Think about my slice. Not bad, okay? I have one pizza. That same pizza, I have to now share with 100 people. Okay, 100 people. What's happening to each of my slice? Like, what's happening to my slice? My share of the pizza. Okay? What happens if I have to share that same pizza that I share with 5 people? Now I have to I have to share it with 1 million people. Okay? What's happening to my slice? If you think of it like that, you're right. It's actually converging. What is it converging to? What is my slice converging to? It's converging to 0. My slice is basically becoming like nothing. I'm going to be so hungry if I just share the same large pizza with 5 people versus 10 people versus 100 people versus 1 million people. So that's the way you should think about it. Now, if you're good enough, and if you're not, it's okay. Okay? I want you to think about this like this. This is 1 over n. 1 is staying constant. but you keep dividing by a really large number, then what's happening to 1 over n? It's going to 0. Okay, so it's converging. That's a little bit abstract for a lot of you, I know. Okay, so don't worry if you don't totally understand. Just try to think of the two ways. One pizza divided by lots of people, or you can think of 1 staying constant and you're dividing by a really big number. What happens to the quotient? Okay, let's go to the next one. I think by now you all know how to write the explicit formula for this guy, right? If you were to continue this, isn't this pattern, you start with n equals 1, right? But it's actually n plus 1, right? And what happened to the bottom? It's just n. Do you see what's happening there? Yeah, you start with 1. So when you plug in 1, it's 2 over 1. When you plug in 2, it becomes 3 over 2. So limit as n approaches infinity of n plus 1 over n. Now, this one, there's techniques for it, but I think I want you to think of it conceptually, okay? Is it converging or is it diverging? Take a guess first, but I'm sure you're doing a very educated guess. Like n plus 1 is definitely larger than n, right? I mean, if you have a 3 and you have 2, I mean, you could look at these numbers here. 2 over 1, 3 over 2, 4 over 3, 5 over 4. But I want you to think about this. 2 over 1 is 2. 3 over 2 is 1.5. 4 over 3, you know what it is. 5 over 4, you know what it is. But it's definitely less than 2. 2 is the largest quotient. What's happening as it's going further and further? What it's asking is, it's going to infinity. Like a large number. I add 1. And I divide by that same large number. What is it about? So think of it this way. Let's say n is my $1 million. But you know, Cheshin also has $1 million. But I have $1,000,001. I have $1,000,001, and Cheshin only has $1 million. But really, 1,000,001 divided by 1 million is roughly 1. It's really close to 1. So this is actually 1. It converges. Converges to 1. The limit as n approaches infinity of n plus 1 over n is 1. Okay? Does that make sense? I like to think of it that way, okay? It's like this. The number is so big, like 1 trillion. So 1 extra dollar, and I divide it by 1 trillion, that 1 is so insignificant. Okay? So it converges to 1. Let's go to 2468. 2468, who do we appreciate? Okay, if I were to write an explosive formula, we all know that's actually just 2n because n equals 1. n equals 1, n times 2 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So that's 2n. So our explosive formula for that guy is limit as n approaches infinity is of 2n. Now, 2n. Imagine 100. 2 times 100 is 200. 2 times 1,000 is 2,000. 1,000,000, 2,000,000. 2 times trillion is 2 trillion. Is it going to converge or is it going to go on indefinitely forever and infinitely big? This one's pretty easy. It diverges. It diverges. It does not, because the limit, you know what I should do? I should write the actual infinity. This goes to infinity. It gets infinitely larger, right? Therefore, this is infinite, so that therefore it diverges. Okay? You know, I correct myself here too. It converges to 0, that's true. But really the limit, I should do this. The limit is 0 for this one. Okay? It converges to 0. Limit is 1. It converges to 1. Limit is infinite. It diverges. How about the next one? How about you try it on your own? -1, 1, -1, 1. Remember, it's getting infinitely larger. Okay? It's getting infinitely larger. And we know that we could write it like this. Okay? And the explosive formula is this. It's simply that. Okay, what's happening here? Well, it's kind of confusing, isn't it? Isn't it going -1, but sometimes 1, -1, 1, 1, -1? Right? It's confusing. So we say this guy alternates. There is no limit. It doesn't exist. There is no limit, therefore it diverges. It alternates. Limit. Oh, chicos, I'll show you a calculus term. It does not. Limit does not exist because it alternates. So D and E does not exist. Is what you have to write. D and E does not exist. It's a real thing, okay? So therefore, it diverges. If it doesn't exist, it diverges, okay? Any of these concepts is a little bit abstract. So if you have any questions about it, please ask me in class, okay? Let's go to the next 3. How about you try these on your own? Okay. If it converges, give me the actual limit. Limit is a constant number, like a number, right? And then if it doesn't, let me know, okay, if it diverges or converges. Okay, well, welcome back. Hope you stopped the video and you thought about it, okay? So I'm going to go limit as n approaches infinity of 3n over n plus 1. Okay, oh shoot, let me write that prettier. Sorry, remember my pencil's acting funny. Limit, let's set this up, right? And what's given to you is the explicit formula. Oh my goodness, it's the explicit formula. Okay, so it's going to be 5n squared over n cubed plus 1. Limit as n approaching infinity of n cubed plus 2 over n squared plus 2. Now, I'll just stop the video and make sure you have your answers, okay? So, hopefully your answers match this. Of course, I'm going to tell you how. But this one, the limit is 3. This one, well, actually, I'll just write the answer here, 3. Okay? This guy, the answer is 0. This guy, it does not exist. Okay? It's infinite. Okay? It's infinite or DNE. Now, did you match that? I'm going to give a brief description as to how and see if you could understand it mathematically. Or why don't you ask a neighbor, okay? But see if you understand the way I describe it. This is a 3n. This is an n plus 1. They're both millionaires. But this guy is 3 times a millionaire. So it's 3. Because this 1 is insignificant. But if I reduce what's the fraction that's left over, it just becomes a 3. They're growing at the same rate. Because it's just both n. Okay? How about here? This is growing way slower. This one's super fast. So if it's going to infinity, this is super big. This is pretty small compared to this. So it actually becomes a small number over a really big number. Small over a big. It's like the pizza case. You have a small pizza, but you got to share with more and more people. Therefore, it reaches 0. Your slice becomes almost of nothing. This guy, well, the numerator, right? Conversely, this one, the numerator is getting so much larger than the bottom. It's small, right? It's staying very small, but this one's growing and growing. So this one's growing so fast, it doesn't matter what the bottom is. It just goes to infinity. Therefore, it's DNE. Okay? There's more, I'm sure when you were in Algebra 2, you learned something called horizontal asymptotes that you learned and how to do that. I don't really like to teach it that way. I like to explain the way I explained it just now. If you're a little bit confused, let me know. But this is it for part 2 of 9.3. I hope you enjoyed it. I hope you learned something. I know that it's not the most exciting lesson, but it is very theoretical and gives you something to think about, okay? All right. I'll see you in class. Bye.